work on solving systems of linear equations. So our objective is that we can solve those. And we're going to look at three methods briefly to give an overview of them: graphing, substitution, and the multiplication addition method, which is also sometimes called elimination or linear combination. Let's start with graphing. What I'm going to do is I'm going to graph these two equations, and I'm going to look for where they intersect. So I'm going to start with y equals x minus 7. Start at the y-intercept of -7. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Keep going, up 1 over 1, and draw the line. So there's the first equation. Now the second one, if I got it into slope-intercept form, it would look like this. It would be, I'll do it down here. I'd have 2y equal to -3x plus 6. Divide by 2, and you get y equal to -3 halves x, and then plus 3. So you start at 3 on the y-axis, and then you go down 3 and over 2, down 3 and over 2, right there, and draw the line. The equation here, this graph that we're drawing here, notice it has a y-intercept here at 3 and an x-intercept at 2. So that graph, if you look at it, and again, it goes just through like that, okay? Notice that you can get that by putting in x equals 0, you get y equal to 3, and y equal to 0, get x equal to 2. Now, this is where the two intersect. That's what I'm looking for. And if you look, that's at the point of, we've got here at 4, comma, and then at -3. That's the solution of this graph. Now let's do it by substitution. Substitution means you're going to take one, the y equals this, and put it in for the other equation. So what I have is 2, and I take out the y, and I put in its place the x minus 7, and I solve it. 3x plus 2x minus 14 equals 6. I get 5x minus 14 equals 6. Add 14 to both sides, 5x equals 20, x equals 4. When we substitute 4 back into here, 4 minus 7 gives me a y equal to -3. So I have my solution of 4, -3, which is the same solution I got with the graph. The multiplication addition method, what you have to do is you have to get them in standard form is the primary way. You can do it other ways, but primarily get in standard form, line up the x's and y's. So this one is already in standard form, so I'm just going to list it. Sorry, this is plus 2y equals 6. And now I'm going to get this one into standard form by subtracting x. And now what I want to do is I want to get either the x's or the y's to line up as opposites. So I'm going to multiply the second equation by 3, and I get -3x plus 3y equals -21. And this first one I'm just going to list as is. And notice that when I add straight down, the x's are eliminated. I'm left with 5y equals 6 plus -21 is -15. Divide by 5, you get x equal to -3, or y equal to -3. If we put that back in, I'm going to put it back into one of these equations. So you do use substitution. I'm going to put it back into the original here. Y is -3 equals x minus 7. If I add 7 to both sides, I get a positive 4. So my solution is 4, -3. So here we have 3 different methods to solve the same system of equations, and then we get our solution of 4, -3.